Hello students, in today's session of laws of motion, very basics of pseudo force will be discussed through illustrations. In earlier session, very basics of graphs, reconstraints, pseudo force have also been discussed, which you can review on SethiSwiftLearn. I would also like to request if you like the session, please share and subscribe my channel SethiSwiftLearn. Now let's start with the questions. Question is, a block is sliding along inclined plane as shown in the figure. If the acceleration of the chamber, this is a chamber, is as shown in the figure, the time required to cover a distance L along the plane is. Four options are given to you. One of the option is correct, right? Concept applicable and solution. No. Concept applicable. One is pseudo force. Pseudo force. FP. Right? That is equal to mass of object under consideration of observer into acceleration in opposite direction that of opposite direction of that of observer frame of reference. Right? This is regarding to the force. Now, first draw all the forces, all the real forces acting on it, plus pseudo force, right? Resolve the forces along the plane and perpendicular to the plane. Yeah. In most cases, acceleration due to perpendicular forces, perpendicular to the plane of the forces does not accelerate, right? Find net force and find net force, that is driving force along the plane. This is all about the how to find the solution of this one. Now in this case, you see, this body is this weight mg, then resolving this mg cos theta, this is normal reaction and free body diagram of mass m with respect to chamber. Now we have to act one force. Chamber is moving in this direction. So pseudo force will act on this in this direction, opposite direction. Resolving this, इसका एक कंपोनेंट आएगा mg sin theta. Resolving the weight into two directions, one perpendicular to the plane of the surface, one along the plane. इसको resolve किया, this is theta. This will come out to be ma cos theta, upward will be ma sin theta. Right? Now, the net driving force will be equal to mg sin theta plus ma cos theta. Net driving force equal to mg sin theta. That is equal to m into a. Right? Therefore, a acceleration of the block will be m से m कट गया, g sin theta plus a cos theta. Now we have to find the time taken. To find time taken, use the formula s equal to ut plus half at square. This is L. Length of incline is this. Initial velocity is 0 plus half a g sin theta plus a cos theta into t square. Therefore, t comes out to be twice L upon g sin theta plus a cos theta under root. This is the answer. Let's see the option available. G sin theta plus a cos theta. This is option C is correct. C is correct. This component always acts down the plane, right? Next question. Question is, a block is kept on frictionless inclined surface with angle of inclination A, alpha. Angle of inclination alpha. The incline is given an acceleration of A. To keep the block stationary, then A is equal to, acceleration is equal to, we have to find the answer. I have discussed all the concepts. The free body diagram will be, in this case, it is going to inclined plane. I am drawing only the forces which are acting along the plane. Mg sin theta always acts down the plane. And this is moving this direction, so it will move in this direction. So resolve along this. This is theta. So this will become ma cos theta. I am not drawing the surface forces acting perpendicular to the plane of the surfaces, resolving this. Because in the earlier question I have discussed everything. To keep the object stationary, net driving force should be equal to 0. That is, this will be ma cos theta. Ma cos theta should be equal to mg sin theta. Goes, A comes out to be g sin theta upon cos theta. Right? Now, this comes out to be A equal to g tan theta. Tan theta alpha जो भी है उसके ले लीजिएगा. Right? The correct answer is C option. I have taken here theta in place of alpha, right? I will also like to request, if you are new to my YouTube channel, SethiSwiftLearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.